Hello, welcome to GeoAI tutorial number 12. In this video, I'm going to show you how to do wetland mapping using deep learning and GeoAI. So before we get into the details about the source code, I would like to show you the results. So this is the base map is the USDA 1 meter resolution NAP imagery. So this area imagery, high resolution, and the red color here with the yellow outline. So these are all the wetlands that are detected using the GeoAI Python package. And so you can use the slider here to take a look at the results. And it looks pretty nice. You see here, it's pretty cool. And all you need is just a couple minutes, train the model, and then you can use that to detect wetlands also in other parts of the globe. Of course, it's not going to be perfect, but it's really low effort and it performs much better than traditional pixel-based classification. And you can clearly see here, for example, even for some of these waters have different colors, depends on location. For example, some of these waters are very turbulent water, so you have some wave. These, I mean, if you use other machine learning approach, it's very challenging. They might not be being detected as the same class, but with this, now it's super easy. So I'm going to show you how to do that step by step, and you can easily adapt this one to detect wetlands in the US or in other parts of the world. As long as you have some of this imagery, and you can use the pre-trained model to do that pretty easily. Okay, so let me show you how to get it. First, you need to go to the GeoAI website, and then on the left side, click the examples. Scroll down to find wetlands mapping. So click this one. Then you can either open this one using Google Colab, or you can download this one to run on computer. So if you want to run on Google Colab, make sure that you enable the runtime. So change the runtime type to GPU. It's going to be much faster. Otherwise, it's going to slow. Cancel. I've already have this one on my computer, so I'm going to run it on my local computer. And if you want to learn more, you're welcome to check out the YouTube channel. So this is tutorial number 12. I have previously covered 11 tutorials from installing the packages and also how to do object detection for using the package. So I've already have this one on my computer, and I'm going to show you step by step, but I can show you here. So this is just one line of code to train the model. I can show you. And this one takes, I think, roughly 5 minutes. So, and after that, you can just use the model to run reference on any imagery. I can show you just the result. This one, for example, I have 609 image tiles and also 609 labels. And so we trained it on the imagery for 10 epochs. So for each epoch, it's going to loop through all the image tiles all together. And each time it takes roughly, for example, for each epoch, I think it's over like maybe 20-30 seconds. So you add them all up. And you can also see the increase of the validation IOU. So IOU means intersection over union. So that means the pixels they're being detected as wetlands compared to the ground truth. So the higher the better, the value range from 0 to 1. So at the beginning, in the first epoch, it's only like 55, and then it's increasing from 60.66. It fluctuates a bit, but eventually it gets to over like 0.82. So that means it's roughly 82% of the pixel being detected. You can, I only train 10 epochs. You can train 100, 1000. You're going to get a much higher accuracy. But again, it only takes you 10 minutes, and then 5 minutes, you can get the result. So let's start from scratch here. I'm going to clear my outputs, and then I'm going to show you step by step how we're going to do that so that you can adapt this one to other regions. So the first step is to import the library. So we're going to use both GMap and also GeoAI package. So first step is to import the library, and then we're going to download some sample data. So these are some sample data that I downloaded from the USDA website. You can click the link here, take you to the Hugging Face. I only tried on 2 imagery, but you can also test other images if you want to. You can also use your own data as well. Once we have the sample data, the link URL, then we can just download the imagery using just one line of code. So we want to download the data to our computer. So these are the two images. One is going to be for training, the other one is for doing testing. If you want to see some metadata, you can call the print raster function to pass in the URL, and we don't want to show the preview because we want to show it in the interactive map. But this will give you some basic information. And this USD imagery is 1 meter resolution here. It has 4 spectral bands, so it's an RGB and also near infrared. Compared to most of the deep learning models, most of them are trained on just RGB, but in this case, we're going to train using 4 spectral bands altogether. You can also see the coordinate system, how many pixels, how many columns, how many rows, or something like that. You can also see some of the statistics, mean, maximum mean, and standard deviation. So all the pixel values range from 0 to 255. Once we have the imagery, we can view them interactively. So call the view raster function and passing the URL. So this is what it looks like. This is the original imagery, and this is the one that we're going to use for training. You can zoom in to see more details. Clearly see here, this is all the wetlands, and it also includes the lakes. So all the lakes, even some of the large lakes is one type of wetlands, but they also have different type of wetlands. I will show you later, but for now, this is the imagery that we want to, use for training. You can also look at the imagery that we're going to use for testing. So these two imagery actually are adjacent to each other. This imagery is to the left, this one is actually to the right. And like I said, I also have some other images in here. If you want to test other images, you're welcome to. So with these two images, next let's try to download some label, because in order to train the deep learning model, you need to have the labels. And what we're going to use, because we're going to detect wetlands, we need some wetlands data. You can go to the US National Wetlands Inventory. So this is the one that has the most comprehensive data set wetland for the entire US, and it's massive. But keep in mind, this data set is not very up to date. Some of the data that were delineated manually in the 1980s, 1990s, and some of those might have been very outdated. But we can still use the data to do the training, and you can apply the model, after you train the model, you can apply to detect wetlands in more recent images. So maybe you can do some change detection, something like that. And so next, let's see how we can download the data. So we're going to use leaf map, but first let's load the imagery. So I'm going to show you video imagery using leaf map. So in this case, we're going to display using the first color composite. As I mentioned earlier, we have 4 spectral bands, right? So if you 412 means the 4 is the near infrared, and then red and green. So this is why you see the red color here, and this is the imagery. So for example, this is the one we want to use for training. Then how do we download the wetlands data for this area? Very simple. All you need is just basically draw a rectangle. So I'm going to draw a rectangle around this map area, and that's it. So leaf map going to grab the bounding box for this area, and just run this code block here. Is going to basically get the bounding box, and then you can use leaf map bbox to GDF to convert this one to a geodata frame. So just one line of code, and then this is where we download the NWI data, so National Wetlands Inventory. So we have the bounding box geometry, and then call this function. Then it will automatically grab the data for this specific area, and take a look. Just couple seconds, we have the data as a data frame, a geodata frame, and these are all basically all the columns. It has a lot of columns, and also it has the wetland types. So we're going to show you, for example, what's the type of each wetland, and also the size, the shape. Also have some other attributes, but for us, we only need the polygon. We just need the shape, and that's it. So once you have the geodata frame, then we can just call this add NWI function to add this one to the map. Also, you can specify the column name is the one you want to use for the symbology. So let's just run this one. It should take a couple seconds, then scroll up to the top here, take a look. So now we have all the wetlands that we have downloaded for this region, and you also on the right here, you can see the legend here. And this is where, let me move my camera here. So on the right here, you can see basically all the attributes. When you have a mouse, it's going to show you all the attributes. So for example here, look at this, all the attributes. So when I hover my mouse, it will be updated. Also, you can see the legend here, show you different type of wetlands, right? So basically for the blue color, those are the lakes. And for the green color, those are the freshwater wetlands. Also, there's some like emergent wetlands or forested wetlands. So these are, for example, for this one here, these are actually all the freshwater emergent wetlands. If you look at some area, they have a lot of forest, you might have this like dark green color. Those are the forested wetlands. And also some riverines. So in this area, this is the area covering North Dakota. So most of those are open water wetlands, has open water body, and most of them are just seasonal, temporary wetlands, and they don't actually have water cover all year long. You can turn the layer on and off. You can see to the comparison. Clearly, I mean, the training data is not perfect because the data in this area, I believe, was designated in the 1980s, 1990s, and I'm not sure if they show the dates in here. Anyway, so because I work on wetlands previously on this area, so I know the dataset is quite outdated. The net imagery that we downloaded, this one is from 2010, so it's 15 years ago. It's kind of pretty close. If you use the latest imagery, you might see larger differences, but at least for now, it still makes sense. I mean, the data still align pretty well, although the water body right now changed so much, right? So look at this one. This is the boundary, and this is the water extent. And some of those might have already dried up. For example, in this one here, right now, this one is no longer wetlands. So some of other smaller polygons in here, again, I'm just trying to show you that the training data is not perfect. We are just using this as sample, but you're welcome to develop your own training data to make it better. Then you're going to get much better result. But even with this not perfect training data, we can still get pretty decent result when we do the training. Okay, so this is the sample data that we have, and the next step is to download the data to our computer. So because it's already a geodata frame, so we can just simply to file and then to download this one to our computer. So 967 records. That means in this area we have 967 wetlands polygons. And the next step is to create the training data. So as I covered in the previous tutorial, all we need is just imagery covering the area and also some label data. So the data can be just a vector data set or it can be a raster data set. In this case, it's the GeoJSON that we downloaded from the previous steps. So all we need to do is just set an output directory and then just call this export geotiff types function, passing the raster and then also the output directory. And this is the vector data. We're going to use the label, set the tile size 512 by 512. You can customize this one because in this area we have a lot of large wetlands. So we want to make sure that most of the tiles can cover the wetlands, and also to basically offset the stripe when you are doing the sliding window. So just run this one. It should take you just a couple of seconds. It's going to basically loop through the imagery and then subdividing into smaller pieces. So all the output will be 4 band, okay, 4 band imagery and also a corresponding label to each imagery. And in total, we're going to generate 609 image tiles because they have some overlap. And lastly, you're going to show you the output. So you here, and tiles exported 609 tiles with features. That means for each tile, whether or not it has wetlands, polygons, I mean overlap with this, the answer is yes. So it's all exported. If you want to check it, you can go to your working directory, and these are all the images. So if you click this one, images, these are all the image tiles that has been generated. It's a lot, right? So 609, it starts from 0, so it's 608. And overlay on the if you have your mouse, you should see each one roughly 1 megabyte, and it's GeoTIFF format, so it's also georeference. You can also open this one, load this one to visualize if you want to. So similarly, all the labels. So earlier we have the vector data set, the GeoJSON. It has been converted to raster and then subdivided into smaller pieces corresponds with the image. So now we have one-to-one relationship. So for each image, we have each tile of the label tiles to correspond to that one. And then after that, you can just start doing the model training. So this is the one that takes the most time. It takes probably roughly a couple minutes. And so what you need to provide is just the images and then the labels where you want to save the models. Okay. So right now, if you look at this one here, earlier I already trained the model. So actually already generated. And all you need to do is just run this one. Then you should be able to train the model. And then once you have that, you can use for run the reference. At the beginning of the video, I actually already show you that. So I'm not going to run this one because it takes time, but you're welcome to train this one using your own data. Just run it, wait for a couple minutes, then you are ready to go. So look at the IOU. So you want the IOU to be close to 1. So at least maybe 0.7, 0.8, right? So those are pretty decent results. That means the prediction, the validation result has at least 80% overlap with the union. That means they have roughly more than 80% overlap. So once we have the models, it's going to save the output to, for example, here, to the models directory and then the base model. So this is the one that you can use to run referencing. So this, you can think about this is the pre-trained model that we generated using this one. So once we have this, now let's run the reference. So we have specify the output where you want to save the output mask and what's the model you want to use. So this is the one that's output from the previous step. So run this one, then we can call this object detection function to run the reference. So what we're going to do is to run the reference on the testing imagery that I showed you earlier and specify the output, which model you're going to use. The window size, basically the image chip size. So you want to be the same as the one when we generate the image mask. So it's the same as the one we put in here. Okay. And overlap size is the same. Confidence threshold. So this one also ranges from 0 to 1. So the higher the confidence threshold, the smaller number of wetlands is going to detect it. And so you can, change this one based on your area. If you think that a lot of wetlands are missed, then you slow this threshold. If a lot of are false positive, then you increase the number. And the base size is depends on GPU. So if you allow GPU, you can increase the base size. The base size means it's 4 images going to be put into the model and then to run to train the reference, run the reference. And the number of channels is like because we use 4 band imagery, so we're going to use channel 4. Just run this one and see how it goes. So as I mentioned earlier, we have 609 image tiles. It's going to loop through all the tiles and then going to basically get the result. And it's not super long. You can see here, it takes probably just 1 minute to run on one USDA image, 1 meter resolution. And once you have the result, it's going to automatically merge all the outputs. And that's it. So you don't have to worry about like how do I mosaic them under who has been done. Once you have the imagery, now you can convert that to vector, because for this case, we want to calculate, for example, how big are the wetlands, how many wetlands or something like that. It's super easy. Just call this function, raster to vector, and then passing the image mask that we generated, the prediction from the previous step. And the output is basically, output is a GeoJSON. You can specify a minimum size. So basically 1000 pixels. Because for each pixel is 1 meter resolution. So we want the area to at least 1000 square meters. And then you can also specify a tolerance, simplify, because when we're going to simplify the outline a little bit, otherwise it's going to be a lot of pixelated, a lot of ruggy edges. So just run this one and that's it. So now we have 427 polygons for this area. Next, let's just visualize the result. So just call this visualize interactive, just one line of code, and then passing your polygon. And we're going to use the base map as the image tile. So take a look at this. Zoom in to see. Upper right here, you can turn the layer on off to see the details. And looks pretty nice. And you don't really, need to spend a lot of time. This is like can be transferable. Like I said, it's not going to be perfect. On the left side here, you see some of those are being missed because some of those are on the edges, along the edge of the imagery. It might not be detected. Also, some of these You can lower the confidence level to see if it's being detected or not. I use 0.3, you can all to 0.1 or something like that. And then you can do some filtering. But I mean, just by simply looking at this visually, it looks pretty decent, right? So all the polygons, you include the water area, but you also include the along the wetlands along the border. Those are basically all the vegetation, the wetland vegetation, and super cool. This will not be very easy to do if you're using the traditional pixel-based classification or other machine learning algorithms, because it's so diverse. Wetlands, for example, the vegetation can be very different. The water can be very different, especially for something like this. The water might have some reflection, might have some wave, and might have different color. They might even have some other floating vegetation. It's traditionally very challenging. For example, in this case, right, you see even some sediment in here, but using these methods, it delineates those very nicely. This one probably is a false detection, but again, you're welcome to adjust the result to see how it goes. And the last one I want to show you is using the split map. So because if you want to compare them side by side using a slider, this is also durable, and I can full screen here, show you the detailed result in here. And let me zoom in to see you more detail. Right, looks really, really nice. Right. It's not bad. You can also compare the result with the NWI wetlands. And you can download the data just like what I showed you at the beginning. You can also download the data for the testing area, and you can compare two results to see how good are the prediction. But keep in mind, as I mentioned, the NWI wetlands, they are delineated in the 1980s, 1990s. So it has been almost like 20, 30 years. It might not be perfectly aligned with these polygons. Right now, we're using the 2010 area imagery, and this is what's delineated based on this imagery. You can also apply this one to do detection on more recent ones, and then you can see the changes of the wetlands in any region around in the US and see how they have changed. I mean, depends on the location, depends on the weather and climate settings. It might be very different, but it only takes you a couple seconds. I mean, a couple minutes. Then you can delineate wetlands so much faster, so much better than the traditional approach. And this is super exciting. You are welcome to adapt this one to do other features. For example, if you are solely focused on lakes, you can also just, if you have the lake polygon, you can just use those to detect lakes. In this case, you will not have the vegetation. If you have the training data just for the lake, just for the surface water, you can do buildings, you can do any other infrastructure, you can do any object that you want. So all you need is just provide the imagery, provide the sample data for labels, and then just use our pre-trained models to fine-tune the model, and then you can compare and see the result. See how cool is this. Okay, so that's all for this video. I hope you find it useful. I will see you in the next one.